Okay, for technician one, you will be already learning about electronic. Okay, and tech two will be quite different. We'll be learning about digital. Okay, that's completely different. So make sure, try to understand, so you're able to do the job. Okay, first thing you can say, oh, that's okay on that one. Okay, now it's working. Okay, you can see that when you're talking to the microphone, this is your voice coming out. Very, very long. So that's why they need to let it go through amplifier to make it bigger. Okay? So that's why they can go to the speaker. Okay. Another thing, you can see this is your CD. When they're coming out, the signal will be binary. That means either one or zero, nothing else. That's what we call digital data. Okay? And basically, they will go to a speaker. However, speaker cannot understand one or zero. So that's why this output must be coming through the device. We call a digital to analog converter. Okay? That conversion will be in your program. Okay? When you learn, you can see how they convert it from digital to analog. So the signal coming out here will be the analog reproduction of music audio. Okay? However, the signal is not big enough, so they need to amplify, make it bigger, so they can go to the speaker. Okay? So that will be telling you two different types of signal. Outside real signal will be analog, and they have to convert it. Okay? Go to amplify, make it bigger. To go to speaker. And anything else, signal coming out from CD, anything other device, normally they come out by binary number. That means either 0 or 1. Then they have to be converted back to the analog, go to device, digital analog converter. Okay, and same thing. They have to make amplify before they go trigger. Okay, now only thing we emphasize, okay, on anything we need, we don't go too much in detail. Okay. However, if you understand the basic, okay, when you go to work, you can learn better. Or you go to engineering level, okay, then they can go into more detail. However, if you get basic understand, will be no problem. Okay? So the first thing we're talking about number system. Okay? First number system, you know, it's a decimal. That means for the human, in a decimal system, they get 10 digits, 0, 1, up to 9. Okay? That will be 10 digits. And that's why they call base 10. That's easy for everyone. The next one, binary number system. In binary, you get only 2 digits, either 0 and 1. And that they get only 2 digits, they call a base 2. Okay? Octal number, we don't care now. We really care about hexadecimal number. The thing that we have to using it. Decimal number system. You get 16 digits. Okay? That means they can go 0, 1, 2, 3, up to 9. Then you get A, B, C, D, E, F. If you count, that will be 16. And that's why we say B 16. Okay? We get only 1, 2, 3. Okay? Number. Decimal, that easy. Binary, only 2. Either the 0 or 1. That's why base 2. Hex decimal, 16 digit, 0 up to F. That's why they call it base 16. Okay? Now, we will be binary conversion. If they given you that binary, okay, and we don't know anything about binary. Only thing we know, decimal. So that's why you have to know how to convert things. Okay? Binary to decimal. First thing, you get 1. Okay? That means you take a 1, you times 2. Okay? Base 2, binary. And now you can say U in here. How many binary left over? 1, 2, 3, 4. Okay, so have to be 4. And you adding to the next one, 1. Now, 2 power of 1, 2, 3. And you adding 1, 0. Okay, 0 we don't care. Okay. And you adding next one, 1. Times 2 power of 1. Last one, 1, 2 power 0. Okay, so that one, 2 power 4. 2 times 2 times 2 times 2, 16. 2 power 3, 8. 0 anyway, 0. Okay, 2 power 1 is 2. And last one, 2 power 0 is 1. You add them up. So 24, 26, 27. Base 10. That is how to convert it binary to decimal. Okay? If you get any question, stop me. Okay? Okay, next one. Decimal to binary conversion. If you get a number 25, base 10, and you want to know what the binary, okay? So right now you see the binary 11001. Okay, this is they show you how to do. Even you never have to do anything. First thing you take 25, divide by 2. Okay, you get number 12. 12 means 24. Remaining is 1. And you take 12, divide by 2. You get 6. Remaining 0. And you take 6, divide to 2. you get 3 remaining 0. You take 3, divide 2, 1. Remainder is 1. 1 divide to 2, you get 0. Remainder is 1. Okay, so 25 by 10 equal, you go back this way. Okay, 1, 1, 0, 0, 1. That's how we converted decimal to binary. Okay, and now if you want hack to decimal conversion, okay, you get 356. Base 16, that means hack decimal. Okay, the first thing you take 3 times 16 base 2, 3 right here, you get a 2-digit base 2, and you add into 5 times 16 base 1, okay, and you add into 6 base 16 power of 0. That gives you this number. Okay, not a big deal. Okay, this just a thing for you guys to exercise. You get hack to binary conversion. Okay, 9 F 2 hack decimal. We need binary. So 9 they have to be 4-bit. 1001. Okay, F okay, 2 later on you get a table showing you. And after you're doing for a while, not a big deal. Okay? So now you can see this is a 9, this is a F, this is a 2. Okay? That means you get a height, you're converting to binary. And now you get a binary here. You're going to convert into the height. First thing you count, 1, 2, 3, 4. 1, 2, 3, 4. Each one will be 4-bit. Okay, 0, 1, 1. That will be B. Okay. 1, 0, 1, 0. A. 0, 1, 1, 0. 6. Okay. Again, you will get a table. Looking into the table. Okay. Then no problem. Okay. We're not talking about any octal. BCD code when a number, letter, or a word are represented by special group of symbols, this is called encoding. Okay, if each digit of a decimal number is represented by its binary equivalent, this produces code BCD. 4 bits required to code each digit. Okay, 874. Okay, so basically number 8 here, 1000. Number 7011. Number 4 here. Okay, it set 3 code alphanumeric code ASC, American Standard Code for Information Interchange. You go into your computer, go to the web, typing ASCII. They given you a table. What equivalent to anything? In electronic, binary represent by voltage or current, but we not deal with the current. We deal with the voltage. And if you're looking in here, okay, they can get V8, that means voltage high minimum and high maximum. That's what they call a high, and that's for binary 1. Okay, that means they already telling you here V8 minimum 2 volt and maximum 5.5 volt. Okay, any voltage higher than 2, less than 5.5, they will be logic 1. Okay, and for low, 0.8 and 0. Okay, from 0 volt up to 0.8, they will be low. Okay, if you get a 1 volt, that means something wrong. Okay, they will be in here. Unacceptable. Something must be wrong. Either they low or high, nothing else. Okay, now you see the signal here. They go 0, 1, 0, 1, keep going. Okay, that's what normally they call this is a clock. Okay, from 0 here up to here, that will be a bit time. Okay, so they can give it to you. Okay, this is a 1. This is 0, 1, 0, 0, 1, 1. Okay, positive going constant. That means you see this signal. They 0, they go high. then go back to zero. That's what they call a positive going. Okay. When they go from T0 up, they call a rising or leading edge. When they from high to low, they call a falling edge or trailing edge. This is the opposite. That means normally high. They go to low, go back to high. That's what they call falling, okay, edge. This will be rising edge, okay, negative going, positive, okay. When you see the signal here, you have to know this is a positive, this is a negative positive. Which one will be leading, trailing, okay, trailing, leading, okay. A portion of periodic digital waveform, okay. If you see this signal, measurement in milliseconds determine the following. You see this is they going up, then they're going up again, okay, and that will be millisecond, okay. So that will be T going from here to here. They will be period, okay. If you want to calculate the duty cycle, you take TW divide capital T times 100%, okay. This is the TW right here. That means the weight of the high side. Now, this is the signal transmitted. When you send the sending device and you get the signal only one wire, go to the receiver. So the signal transfer will be go this way. That is a serial data. So the serial data transmitted, they need only one wire. Actually, you know where you can see this signal can go. Okay, before we talking about that serial, now I'm talking about parallel. Okay, parallel data. You get 1, 2, 3, 4, 5, 6, 7, 8. That means 8 bit. They transfer to somewhere else. They need 8 wire. 8 bit need 8 wire. 16 bit, they need 16 wire. You know on your computer right now, how many bit on your computer?
Should it be 128 bit
Huh.
or way more?
You know your computer, right? Who knows how many bits in your computer? for address.
64?
Perfect. 64. When you look in detail on your computer, they will telling you 64 bit. They're telling you in your computer they can get 64 wire for address, for location, anything. But inside the computer, they cannot using anything else without binary. Okay? Not serial. Must be parallel. Inside computer cannot using serial. So, go back in the serial here. You can transmit 1,000 bits. Doesn't matter. You need only one wire. And that basically, I can tell you, in your telephone. Okay? On telephone, you're using only serial data. You cannot using parallel data. The thing is you don't have enough wire. They need only one wire. Okay? However, again, inside the computer, they're using only parallel data. Okay, so basically now, if you know decimal number and you want to know binary number, okay, so 0, 0, 1, up to 15, 1, 1, 1, 1, 14, 1, 1, 1, 0. Okay, this is a formula, how to do calculation. Okay, and just for your little understanding, okay, encoder. This is a decimal. And it will be binary. Okay. You know that is in your keyboard, right? You typing number 9. Computer cannot understand number 9. So, encoder, they try to converting number 9 to the binary. Okay? So the computer understand it's the number 9. Okay? On your phone, on your calculator, everything. They need encoder. And the next device, decoder. If you get a binary coming in, okay, when they coming out, okay, basically human cannot understand binary. So that's why they use 7 segments. They will be converting that binary to the number human can understand. Example, if I get a number 8, go to decoder, go to segment, they display number 8. Okay, they can display 0, number 1, 2, 3, up to number 8. Or they can display later on in the character.
I have a question for that number.
Yeah,
So For number 8, the binary code input should be 1000,
Yeah,
and the decoder will just send it to the display.
yeah. 1000.
And
They go
and
to the decoder.
and
Decoder will be turned on number 8 for you.
cool. And for we put in the binary of 9, it'd be 1001. It would just like
Exactly.
change it itself, or we
Yeah,
had to do a program on that.
yeah. They will be gen number 9.
Huh.
Okay?
Okay.
Yeah, one will be computer science. Another one human. Okay? That's why they're using segment. This is just for your example. You try to see. I already given you answer. Convert following binary to decimal. I don't care now. Convert following decimal to binary. No, we don't care that. Now, talking about addition. We can get addition or subtraction. Now, the formula, 0 added 0, you get 0. Sum of 0 with a carry of 0. 0 adding 1, you get 1. Sum of 1, no carry. 1 add 0 equal 1. No carry. Okay, 1 adding to 1. Sum 0, but carry 1. Okay. Now, what that mean, carry 1? Carry 1 means adding 1 to the next column. Okay. And now they given to you example. 1, 1 adding to 1, 1. 1 add 1,
It'll be 0 to the next,
0, right?
to the left of 1.
1 add 1 is 0. However, carry 1. Carry 1, that means you take that 1, adding to 1. 1 adding to 1, 0. 0 adding to 1 is 1. Carry 1. And now you get carry 1 here. Okay? If you say 1, 1 number 3, 1, 1 number 3, 1, 1, 0 number 6, that is how you can add it. Only thing is, this is the 1. You have to know. Only the difference is 1 adding 1. Answer will be 0. Carry 1. And also they're telling you, carry 1, that means adding 1 to the next column. Okay, now subtraction. 0 minus 0, you get 0. 0 minus 1, you get a 1 with the borrow 1. Now, what that means? Borrow. Borrow 1 means subtract 1 from next column. Okay? 1 minus 0, 1. 1 minus 1 is 0. Okay? And this is the 1 given you example. You try to do. Let's see. I can try to see. 1 minus 0 1. 1 minus 1 0. 1 minus 0 1. You see this is number 3. This is number 1. 1 0 is number 2. Okay, we can see 1 1 0 1. Minus 0 1 0 0. One minus 0 1. 0 0 1 1.
0.
Okay, you can try. Okay, if you get problem, you let me know. Now they're talking about first complement. First complement. Second complement. Make sure everything you have to understand. In order you can get better, you can do. But have to be reading what the first complement. First complement of a binary number by changing on 1 to 0, 0 to 1. That's it. Easy. You get a number 1 0 1 1 0 1 0. That's a binary. If you want first complement, 1 change 0 0 change to 1. That's it. Nothing else. Second one. Second complement. Second complement. Adding 1 to the least significant bit of the first complement. Second complement equal first complement adding 1. Okay, now they given you binary here. First thing you need to get first complement. You know first complement converting 0 to 1, 1 to 0. And after you get first complement, you adding 1. That's why you get second complement. Okay, so you can check on that. Okay, example. If you don't know, you're asking me. Okay, sign number. We not deal with that. Okay, sign bit. We don't care either. First complement form. Let's see. That's still a sign number. Okay, if you go up higher level for engineering, you will be learn that. Okay, we don't deal with the negative number. Binary to height. conversion. You get the binary here. They say, I want the hex number. The reason we need to know the thing, we have to using it. So, in order to do it, first thing, you count 1, 2, 3, 4. 1, 1, 2, 3, 4. 1, 2, 3, 4. Then now you're converting for x1. 1, 1, 0, C. 1, 0, 1, 0, A. 0, 1, 0, 1. 5. 0, 1, 1, 1. 7. That heck, that's okay. Easy. Let's see, they given you table in here. Here. This is the table. You see that? Binary 1, 1. One, 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 binary. Hack app. 110 E. 1101 D. Okay. And C and B and A. You get the table. So no problem when you try to converting here. Only thing, make sure you understand. First thing you get 4-bit. Okay. And the next one. 4-bit. 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 Then you're looking into the table here. Okay. You can get the number. Okay.
Yep.
Let's see. Next one. BCD. Binary code decimal. Number 9. 4-bit. BCD. Each number must be 4-bit. Number 0. Number 1. Okay. Now you get 35. Okay. Then you want binary BCD. First number 5. That's 0101. They must be 4-bit. And 0011, number 3, 35. Okay. That is BCD. Add the following BCD. Okay. You can go ahead and try. However, in our program, this is not using anyway. More theory. Okay. So that's why we don't pay attention. Like add BCD number. Okay. You can see how they add 1001 adding to 0100. 1 adding to 0, 1. 0 add 0, 0. 0 add to 1, 1. 1 adding to 0 is 1. Okay, you get the number 1101. You understand one thing. BCD working ở decimal. They go 0 to 9 only. Cannot be higher than 9. Same thing decimal. However, 8 digit they asking for at least 4 bits. Okay, so now when you adding, you get answer will be 1101. 1101, that means 13. We don't have a number 13 in BCD. So that's why they show you invalid BCD number. Okay, that will be 13. Now, what you need, add number 6. Okay, 1, 1, add number 6. One, 0, 1. 1 is 0, carry 1. Carry 1 here. 1 adding 1, 0. Carry 1. Okay, so you can see 4 bit BCD will be, this will be 3. Okay, and 1 will be 1. Basically, they're supposed to be 1, 3. Okay, so that means 13. So when you're adding the number, this is number 9. Number 4, that you're supposed to get 30. However, using BCD, you adding here, they get the number greater than 9. They not allowed. In order to solve the problem, add number 6. Then the answer will be here. Okay? Gray code don't care. That's an easy one. Okay? When we get the time, I can help you. ASCII. Okay? Basically, that's just a table. Okay? They given you equivalent. You go to the computer, typing ASCII. They just given you the table. Okay? Now, law and rule, Boolean. A plus 0 equal A. A plus 1 equal 1. A times 0, 0. A times 1, A. A adding A. A. A adding A, not A. Okay, if you get an A, and now we're telling you, not A, opposite 0. Okay, so A adding not A equal to 1. A times A, A. A times not A equal 0. A not equal A. That means get A here. Not equal 14. You take one not out. One not. Okay. And now you get another not. That means they take it out. Go back A. Okay. A or AB. A. Oh. Okay, now you can put A. Open. You take A out. 1. You take A out. 1 or B or C or D equal 1. Okay? 1 or anything have to be equal 1. Okay? And you get A or B times A or C. And you get A or BC. Now, sum of product. That's what they call the Morgan's theorem. Not X and Y. You take this one out. Okay? You take that out. X will be not X and will be all. Y not Y. Okay? That's a sum of product. Okay? And the next one, product of sum. You get the bar right here. You want to remove that. X will be not X or 10 to N. Y will be not Y. That's only telling you if you get N, you converting, you get all. If you get all, convert it to be N. Okay, now the logic gate. When you say that gate, they will be N. And gate, 2 input, 1 output, and the formula will be Y equal A times B. Okay, this is the IC for the AND gate. Okay, the part number is 7408. This is IC. In the IC, they get how many pins? 1 up to 14. Inside, they get 4 AND gate. This is the gate. 1, 2, 3, 4. When I'm looking into the first one, pin 1 input, pin 2 input, pin 3 output, and so on. Okay? And the IC, they have to get the power and route. Without power route, they're not working. Pin 14 connect to 5 volt. Pin 7 connect to ground. Okay. 2 input and gate. Simple. Okay. 2 table. 7408. Okay. General. One output. Output is 1 if all input are 1. And get you get a 1 0 input 0. Output must be 0. I can give you example here. 1, 3, A, out. If A 0, what out? Out here will be A times B times C. A 0. What output supposed to be?
1,
How come you get 1?
because input was 0.
Input
No,
0.
it's zero. It's zero, Mr. Pham. The
Yeah.
only time you're going to get 1 is if both inputs are 1. If both inputs are 1, you get 1. But if the inputs are 0 1 or 1 0 or
1,
whatever,
0.
it's
Oh,
0.
yeah. Yeah.
Okay, now.
Thank you. Thank you. Thank you.
A 0, 0 here. Times B times C. They must be 0, right?
Right.
Yes.
Anything times with 0 must be 0. Okay.
If somebody asked, say my teacher told me so.
Yeah, I wasn't even looking at the table. I don't know. I don't know. My brain was somewhere else. Sorry.
Okay. So A 0. Output must be 0. If it's not 0, what can you do? What you say?
Something wrong.
They can asking you, what happened on B? The thing is A 0. B can be 1 or 0, doesn't matter. That's why we say I mean don't care. C mean don't care. If you get A 0, you measure the output. You cannot get 0, you say, go ahead and change that out. That's great. Sometimes they try to trick you. They can ask you, how come you not take B? The answer will be A 0 output must be 0. B or C will be don't care. What they mean don't care? Don't care mean either 0 or 1. Doesn't matter. Okay? So that's why they're telling you right here. Output is 1 if all input are 1. Okay? 1 input 0, output must be 0. That's it. Easy to understand. All get. Okay. Symbol here. Input A and B. Y equal A or B. Okay. And this is the IC. Okay. You can see they get IC 14 pin. Okay. 1 get all, 2, 3, 4. Okay. Pin 1, input all, first all, pin 2, input, pin 3, output. You're looking into here. You recognize what pin is the in or out of which gate. However, the part number 7432. Okay. And they telling you one thing. Output is 0 if all input are 0. One input is 1 output must be 1. 1 again. I telling you, if you 1, all 1, all 1 equal what? Make sure you understand binary. If I get 1, all 1, all 1, all mean adding. Who can telling me? I don't want you telling me number 3.
1.
1. Perfect. If you say 1 adding 1 adding 1, you get 3. No. 3 is not a binary. We don't have a number 3 binary. Okay? You can get 10 number 1 adding, you get what?
And if it's 1 0 0, it'll still be 1
No.
because it's all inputs are still has to be all inputs need to be 0 to be 0.
Okay. Now, in the circuitry here, you understand the 5 volt. 1. Round. 0. If I telling you pin 1 connect to 1, that means you connect that to 5 volt. That's a 1. So in the binary, here you can only work with the 5 volt for logic 1 and round for logic 0. If you say I connect output here to 1, now how can I connect to 1? That means you connect to 5 volt. Okay? Output is 0 if all input are 0. Okay, this is easy. Inverter. Okay? Part number here. 7404. Inside the gap, 1, 2, 3, 4, 5, 6 gate. Pin 1 input, 2 output. Okay? And basically inverter. That means if input 0, output 1. Input 1, output 0. Okay? That's easy. That means the NAND. Okay? I want to stop at this point. Now I tell you. Monday coming. You guys will be, if you're looking into the schedule, Monday, 4:30. There I get lecture in room 240. Okay? So that next week, no Zoom on Friday. That means if you get lecture in the class, then that week you don't have a Zoom on Friday. On Tech 2, I want to get more time in the class in order to help you. Okay? More easier than on the Zoom.
Sounds good.
Yeah, that's
Good,
what
good.
I try to think. Which way is better way to helping your guy know how to do what to do. Okay? So normally you don't have a much the Zoom on Friday. Everything to me. Okay? I can set up so you can get a lecture on Monday 4:30 to 6. Okay. When you start doing the lab, you get the circuit board, you get the IC, you get the wiring. You can build your circuit at home. Okay? You don't have to go into the class. However, make sure you have to sign every day. Only Monday, Tuesday, Wednesday. Thursday, Friday. Okay. Not sign anything. Okay, any question? Anything?
Hey, Mr. Pham, on the D Lab 2, did you open up those cells that were locked?
The new one.
Say again?
What you say?
On D Lab 2, the cells for A and B were locked. Did you unlock them?
We'll see.
D Lab 2.
Okay. Let's see.
Maybe I don't know, maybe Ty or somebody unlocked them. I don't know.
Okay, just 1 minute. Okay, let's see. I stop that Zoom. Okay, and I talk to Mr. Smith quickly. After that, I make the recorder. Let's see.